If you take care of these four things, you are not going to get a beating for your RAG project in production. Not 10 things, not 8 things, just these four things you need to take care to make your RAG meaningful. Let's see without any delay. Okay, guys, so as usual, we will understand what are the culprits for your RAG failure. And as I told you, you need to take care of four things mainly. And if you take care of these four things, your RAG will be usable. Okay? Nobody can say you that your RAG is not usable at all, which is a big problem in the world of RAG. So, what are the things we will understand first? Then we will understand how can we avoid that. And then, of course, I will show you a Python demo where we will do side by side comparison of one naive RAG, which means normal RAG, and another one with fixes implemented. So, first of all, what are the things we will focus on? What are the problems with RAG? The very first problem that you will find with any RAG system in production is the knowledge itself gets updated. Please understand this very carefully. Knowledge updates. The meaning of this is suppose OpenAI's GPT 5.2 price today is $20 and tomorrow it becomes $18. What should happen is this updated knowledge should flow to your RAG. And then only if somebody comes and asks your RAG, what is the price of 5.2 ChatGPT model, your RAG will say the new price. So the one challenge with normally RAG is how do you manage these knowledge updates or knowledge versions? I will show you this in example now. The second problem with RAG is since we are talking about lot of information retrieval here, okay? So the problem which makes your RAG slow and useless is retrieval decay. How do you take care of retrieval decay, or what do you do that retrieval decay is little better? So people take various kinds of approaches, but one approach that we are going to take today is basically a combination of semantic plus lexical search. And if you do that, retrieval decay will be you can work better with the retrieval decay part. Third is basically how do you filter the chunks? Very, very important part here. How do you filter the relevant chunks? This filtering mechanism, right, has to be a layered approach. Otherwise, what will happen is it will keep giving you irrelevant information. Okay. So, filter chunks, there is not one way to do that, but I will show you one approach where 2 to 3 layers we will put and we will filter the relevant chunks. Okay. And last but not the least, if you are getting the faithfulness or if you are getting the goodness of your response, right, then you can be little confident that your RAG is doing good. So evaluation mechanism has to be there in the RAG no matter how you do it. You do it through human in the loop, you do it through LLMs, you do it through some presets of things or however you do it, right? There has to be an evaluation mechanism which can tell you that I think this is the problem and maybe this area is the problem and guys go ahead and fix it, right? So if you take care of these things, one thing I can guarantee you is your RAG will not be useless. Nobody can see you that what you have built it's of no use, right? As usual, what we will do is we will go to GitHub and I have uploaded a project here in GitHub. If you go here, right, there is a project, the four reasons of RAG failure and how to fix them. Okay. This project demonstrates why most RAG systems fail in production and how to fix each failure. Please pay attention here. First one I told you knowledge drift. What is the meaning of knowledge drift? Source data changes, but the retriever still returns outdated information. As I give you ChatGPT example, the model confidently answers with stale facts, means not updated information. Fix is implement version awareness. I will show you how to do that now. Track document versions and automatically re-index when data changes. The fixed track system detects version mismatches and refreshes the index. So if you have a version of the things, right, you can refer to the latest version. Retrieval decay. As data size grows, retrieval quality drops. Pure vector search misses critical documents. Recall degrades silently. Hybrid retrieval combines lexical search, as I told you, and semantic search. BM25 captures exact keyword matches while embeddings handle semantic similarity. And if you put a combination right, this improves recall across corpus sizes. So that is what we are going to use. Irrelevant chunk injection. So this is again one more problem. Your chunks are meaningless. As I told you, we are going to do a layered approach here. So intelligent chunking preserves semantic boundaries. Context control limit tokens and filters by relevance score. A summarization layer reduces noise before generation. So we will put three layers here: context control, filter, and summarization. Okay. Evaluation gaps. No feedback loop, no quality metric. As I told you, if you don't see these things, right, then how will you know that if it is doing fine or if it is not doing fine? As usual, we will build two racks. Broken rack system A, which will be simple vector search only, naive chunking, no version, no context, no evaluation. I will build a fixed rack, which will be a hybrid retrieval, intelligent chunking, version awareness, context control, summarization, and continuous evaluation. Right? Very simple to run. You can simply go and do this and run app.py. First of all, let me show you how this is running. So if you see here, right, there is a folder called data. Okay. And there is nothing inside data folder now. So if you can see here, right, nothing inside data folder. When I run first time Python app.py, okay, you will see that this data folder will get updated with some files, and that is nothing but my data generation running. So see this data generation. Here I have some data. For example, these are my documents. Document 1 is company product launch. Okay. Our company launched a revolutionary AI assistant. The product features advanced NLP, blah, blah, blah. Pricing starts at 20. Please remember this. I will refer to this later. Pricing starts at 20 per month. Basically, this is talking about an AI product. The pricing is starting at 20. And this is what the document says. Okay. Version is 1. Right? If you go to this one, right, you see that now these documents have been created. Version 1, okay. Our company launched a revolutionary AI assistant, the product featured, and this is 20. Fine. This is version 1. Similarly, for other documents, you will see version is there. Version 1, version 1, version 1. What is happening in data generator is, if there in the front end, right, I can basically mimic the data version upgrade. Okay. For example, if I go to the front end, right, let me try to show you what I'm seeing. If I go to the front end and I ask a question, for example, what is price of which product we are talking about here? What is price of a revolutionary AI assistant? Just this much only I'll say. Query both systems, right? When I query both systems, you will see few things are different between these two systems. System A is on left, system B is on right. The price of this is 20 per month, which you saw in the knowledge source as well. The price of this is 20 per month. This is fine, no problem, okay? But you see the retrieved context here. Lot of things have been retrieved in the left hand side, which is not needed basically. Okay? Right hand side, the retrieved context is just what you need. Okay? So if you see the score is 1, this is the context you need and this is the information you need. That's it. You no need to keep fetching multiple things and keep confusing, right? Relevance, faithfulness, answer quality, context utilization, and latency score. All these things I am generating from evaluator. I'll show you now. So let me show you that. From evaluator, right? All those things I'm generating. See, relevance score. Rate the relevance of the following in the context of 0.021. So I'll just ask ChatGPT to generate this. How faithful is the answer? Um, and whatever you saw there, right? So, for example, respond with 0 to 1, all those parameters that you saw, similarity between answer and ground truth, etc. Okay. So I'm generating from this and that you are seeing on the front end. Okay. Now this is fixes applied. As I told you, here we are doing hybrid retrieval, intelligent chunking, context control, summarization, and version awareness. Here irrelevant chunk injection is happening. There are no evaluation. Pay attention here. Indexed version is 1 and current version is 1, which means current data version is 1 and the chunks is also coming from version 1. Here also indexed version 1 and current version 1 synced. Now what I will do is I will check this box here. Simulate data update knowledge drift. Okay. I will simulate this and I will say query both systems. Now one important thing will happen here guys. When I do that, right, you will see that version is updated to 2 here. Okay. Not only version is updated, the information also is updated. If you come here, right, you will see pricing now starts at $15. Okay. Pricing now starts at $15 and this is second version of your knowledge. Go here and see the response now. You see broken rack system. The price of AI assistant is 20. Why? You know the answer. See here. Indexed version is 1, but current version is 2. Meaning index not refreshed, showing outdated information. Because data has been updated, but since we are not indexing it, it is not able to refer it. Okay. And hence it is giving you incorrect information. Now ignore these things for now because these are anyway chat GPT generated. This is giving good number, but it's not a good number. It's an outdated information. Okay. As usual, lot of chunks here. Some are useless. Right side, absolutely the chunk you need. 15, which is your current price. All these things are good again. Fixage applied, and this is most important. Index version 2, current version 2, which is synced. Right? So remember, we are trying to solve 4 problems here. Knowledge updates, retrieval decay, filter chunks, and evaluation mechanism. Evaluation mechanism I already showed you. That is basically I'm doing from this script, evaluation script, evaluator script. But let me try to show you the knowledge updates and other things how I am doing. So if you go to this is again this will be a broken rack. So in the broken rack there is nothing much. Okay, the chunks will come, the response will come, the normal embeddings will be done. Okay, self-taught embedding model dot encode, and as you can see there is one embedding done and then matching will be done and response will come like normally, nothing additional here. Okay, and there are some things here which will just give the explanation, which is fine, but this is your normal rack. You have seen this, enough of this. Okay, sentence transformer it will use and blah blah blah. Now come to fixed rack. In fixed rack I want to just have your attention on few things here. First thing is, where are we mentioning that data version should be controlled? So if you come all the in, right, check version mismatch. Okay, here we are checking the current version, max of d dot get version for d default one. So it will get the max version. Okay. If there is a version mismatch, right, you will see that I'm calling this on the top and I'm saying that, see, I'm calling this on the top version mismatch and I'm saying if you find that, then take the latest version. Let me search here version mismatch only. I had searched this before. See, if self-taught check version mismatch, if this happens, then take self-taught index. Okay. And index will come from where? You know this, right? Index will come from here. This is your how do you take care of versioning part. The one part I want you to have attention is how I am taking care of retrieval delay. Okay. So I told you there is two-fold approach here. One is lexical and one is semantic. So for here, right? Where is that? Yeah. See here. Self dot embedding model dot encode. This is your embedding part, and BM250K API is your lexical part. And here you are combining both these things. So embedding is also there, and BM25 indexing is also there. If you do this right, what will happen is your retrieval decays. I mean to say, when the knowledge source grows beyond a limit, right? Then you want the latest information or better information, right? So if you do these kind of combined approach, you are going to get that. Now, one important thing here is intelligent chunking. This is again applicable when your knowledge source grows. You don't want garbage in your rag, right? So three things are done here, guys. One is filtering. Okay. Another one is, so see here one by one. For sentencing sentences, right? See from here to here. Okay. What is happening here is it is running a three layers of approaches. So go to read me once. This is a different way. Go to read me once. And you see here, intelligent chunking preserves semantic boundaries, context control limit tokens. Okay, the first part that you are looking now, context control, and filters by relevance score. Then the summarization layer will come. So if you go here, right, again, intelligent chunking, right? So if you see current tokens, target tokens, so it will limit your context length. And then in the hybrid return, right? So basically these things are coming from the top that we are doing two kinds of BM25 and this one, right? So here filtering context is also happening. So if you see here, right, it will take the items and it will see previous token and this token, and it will return you the filtered result, and then it will summarize the following retrieved context, focus on information most relevant. So it will summarize. So what will happen is the context that you are the chunks that you are going to get, right, those chunks will be more meaningful. You are not going to get garbage chunks. Okay. So here summarized context is going as input. If you see context is summarized and question is query. So all those things will help give you better chunks. Okay, that is your chunking part. So these are something that we are putting on the front end, basically habit that you saw in the front end, right? These things. Okay. And yeah, that's it then. If you these are your answers, context, latency, etc., that you see on the front end. Those four things applied, and anything you ask, right? What will happen is when you query both systems, if I run it one more time, for example, and if I say simulate corpus growth, so retrieval decay also you will see here. When the corpus grows, that is how the data generator is written. Okay, what it will do, it will help you simulate corpus growth. So let's run one more time on the same query. Okay, and it will take slight time because it is simulating the corpus growth, and then retrieval decay you will see. So the price of revolutionary AI again 20. This is wrong answer. The right hand side system is working really well. And here for failure modes detected, knowledge drift has happened. It is not giving irrelevant chunk. It is giving evaluation gap. It's not, basically I'm putting here, but not too much great quality of evaluation. And here as you see, index version 3, current version 3 synced, index version 1, current version 3. So left hand side not updating the data version. Okay. So this is how you need to understand how to build a better rack. Take care of your updating your knowledge, take care of your matching, take care of your chunk filtering. Now, as I told you, chunk filtering can be done in multiple ways. Okay. Here I have taken one approach. You can take a different approach, and then evaluation. Okay? Again, I'll give you this project, guys. Rag your culprits. This is on my Unfold Data Science. Take it, read from it, change it, and let me know how you are able to run it. See you all in the next video. Available. You are stay safe and take